that mean? This means whatever you put in and you take the size, it's less than 1. So what can we put in there?
Fraction.
Right. It's all the numbers in between -1 and 1. This actually means the same thing as this. Right? Any number you put in here, in this range, if you plug it in here, and you take the absolute value of it, it's going to be less than 1. So what does that mean then? Any number you plug in there, and you take the absolute value of it, it's going to be greater than 2, right? So clearly x is greater than 2 is such number. What else? Less than -2, right? That's what it means, okay? What about this? This is kind of weird. You take the absolute value of it, and it's between 1 and 2. What kind of numbers are those?
Between 1 and 2.
Well, clearly between 1 and 2, right? Clearly. What else?
-1 and -2.
Right. -1, yeah, greater than negative, so it's like this. Switches, right? The location switch between -1 and -2. That's what this means. Okay? Does that make sense? So I have here in the first, this first statement here, that at 1 and -1, the first derivative is 0. So I can replace that with 0 and 0. Okay? Okay, so that's used. It's negative when it's between 1 and -1, right? So you put negative through here. Okay, so that's taken care of too. Everybody, it's okay up to there? Here it says the first derivative is positive. Here, so between 1 and 2 it's positive. Here it's positive. Good. Here it says it's equal to -1. So it's actually like a constant slope here.
Oh, so it's not just negative.
It's not just negative. Actually, no. So right now what they're telling us is this. The slope is -2 like this. The graph is a straight line there. Okay, so we'll worry about that later. Okay, I don't know what kind of... This has got to be like a piecewise function. Okay, they sort of separated the straight lines at the end. Okay, now, so this one actually, you know what? I'm going to highlight because it's a little bit special. Right? What do you mean by -1 instead of being negative, right? So we have to be a little bit more careful with attention to detail when we're drawing it. Okay, the second derivative is negative between -2 and 0. Okay. And there's an inflection point at 0, 1. So x equals 0, right? So I'll put 0 there and it's an inflection point. If there's an inflection point, this has to be positive right after. Right? It has to change. The negative curvature would have to change from negative to positive, right? Now there's some empty spots here. Okay? And it's sort of up to us. Okay? It's not the inflection point, okay? There is no curvature here because this is a constant slope. Does that make sense? It's actually going to be 0 here, but it's not an inflection point. It's just constant, right? Constant slope, right? Yes, Andrew? So here, it's sort of up to us, right? As long as we draw the curve that satisfies given condition, we're good. So I'm gonna change color. I'm just gonna make it up and say that's positive 2. It's okay, because as long as I don't break any of the conditions when I draw it, I'm drawing the right curve. Okay, so this is made up by me, right? Okay, let's fill in the curvature now. Okay, this is going up, curving down, going down, 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 up, and this is up, up, right? Okay, so you can see that this is going to be a local max, and this is a local minimum. Okay, so let's draw this part first. So at -1, it's a max. At 1, it's a minimum. And the inflection point is at 0, 1. So that point is given. It has to pass through this given point. And curvature has to change at that point. Oh, that's really horrible. Okay. That's pretty horrible. Like, it shouldn't be this steep. Like that. Okay. And then something weird happens at 2. So let's continue our graph until 2. Here's 2, right? Okay. Here's -2. So I'm just going to continue my curve naturally up to that point. And then the slope there has to be -1. It has to be -1, okay? So -1 looks something like this, right? So that's what the graph looks like. Does it have to meet like this? No. It could be a jump, discontinuity. It could be down here. But I just connected it. It looks nicer. Okay. But if you drew it like off, it's still correct.